Let's talk about a few more data mining and machine learning techniques people will expect you to know about. We'll start with a really simple one called k-nearest neighbors, or KNN for short, and you're going to be surprised at just how simple a good supervised machine learning technique can be. Let's take a look. So let's talk about some more data mining and machine learning techniques that employers expect you to know about. There's a few more that we haven't covered yet. One of the simpler ones is called k-nearest neighbors, so let's start with that. Sounds fancy, but it's actually one of the simplest techniques out there. The idea is, let's say you have a scatter plot, and you can compute the distance between any 2 points on that scatter plot, right? So the idea of k-nearest neighbors is, let's say you have a bunch of data that you've already classified that you can train the system from. If I have a new data point, all I do is look at the k-nearest neighbors based on that distance metric and let them all vote on the classification of that new point. So let's take an example here. Let's imagine that this scatter plot here is plotting movies, and maybe the blue squares represent science fiction movies and the red triangles represent drama movies, okay? And maybe this is plotting ratings versus popularity or anything else you can dream up. So we have some sort of distance that we can compute based on rating and popularity between any 2 points on the scatter plot. Let's say a new point comes in, a new movie that we don't know the genre for. What we could do is say, let's set k to 3 and take the 3 nearest neighbors to this point on the scatter plot. They can all then vote on the classification. So you can see if I take the 3 nearest neighbors, k is 3, I have 2 drama movies and 1 science fiction movie, and I would then let them all vote, and we would choose a classification of drama for this new point based on those 3 nearest neighbors. Now if I were to expand this circle to include 5 nearest neighbors, k of 5, I get a different answer. So in that case, I'd pick up 3 science fiction and 2 drama movies. If I let them all vote, I would just end up with a classification of science fiction instead. So you can see the choice of k can be very important. You want to make sure it's small enough that you don't have to go too far and start picking up irrelevant neighbors, but it has to be big enough to enclose enough data points to get a meaningful sample. So often you'll have to use train test or a similar technique to actually determine what the right value of k is for a given data set. But at the end of the day, you have to just start with your intuition and work from there. That's all there is to it. It's just that simple. So even though it is a very simple technique, all you're doing is literally taking the k nearest neighbors on a scatter plot and letting them all vote on a classification. It does qualify as supervised learning because it is using the training data of a set of known points and known classifications to inform the classification of a new point. But let's do something a little bit more complicated with it and actually play around with movies, just based on their metadata. So let's see if we can actually figure out the nearest neighbors of a movie based on just the intrinsic values of those movies, the ratings for it, the genre information for it. So in theory, we could recreate something similar to customers who also watch, this is a screenshot from Amazon.com, just using k-nearest neighbors. And I could take it one step further. Once I identify the movies that are similar to a given movie based on the k-nearest neighbors algorithm, I can let them all vote on a predicted rating for that movie. So that's what we're going to do in our next example. Let's get to it. So there you have the concepts of KNN, k-nearest neighbors. Let's go ahead and apply that to an example of actually finding movies that are similar to each other and using those nearest neighbor movies to predict the rating for another movie we haven't seen before.